This e-learning module has been produced by the Micronesian Centre for Sustainable Transport with funding from the European Union. This presentation was prepared for the 2018 Pacific Islands Transport Forum and Expo hosted by the University of the South Pacific in Suva, Fiji. Professor Capt. Michael Vahs presents a 13-minute summary of technical and operational measures available today and tomorrow to Pacific shippers looking to decarbonize. While there is a growing range of such measures, Professor Vahs reminds us that it is our human capital that will be our most valuable asset in undertaking change, and long-term, sustained capacity development is essential.
Hola everybody, my name is Michael Vahs from Hochschule Emden-Leer, University of Applied Sciences, which is located at the north coast of Germany. So I'm glad to participate with you in the webinar on maintaining a 1.5 degrees course to decarbonize Pacific shipping. So the question we are focusing on is what are the technologies available today and what's on the horizon for Pacific scale shipping. Let's start with an overview. What are the low carbon options available today? First, more in general. Later on, we will have a specific look at the Pacific Ocean region. So there are three different main categories. First, let's have a look at the ship design. So what makes ship design more energy efficient? First of all, speed down. By putting the speed down, we can save a whole amount of energy. At the same time, we need to keep up the transport capacity. That means we would have to put up the capacity for the speed compensation. After all, we need high efficiency of the ship's hull and all systems. Second category, use of low carbon and clean energy. So we need to change over to low carbon fuels and finally to direct renewable energy like wind and solar. Third category, smart ship operation systems. This includes specifically our human resources and information technology systems. So we want a system of continuous improvement of all processes. That means checking and measuring, analyzing, improving all processes with the support of IT systems and of course a lot of training for the crews. Let's look at more details. One of the most effective measures to save energy is reducing the ship's speed. This can be demonstrated by looking at the so-called Admiralty coefficient equation. This demonstrates that the power demand of a ship will rise with a third power of the speed. That means doubling the speed of a ship demands 8 times more power. On the other hand, reducing the speed to half of the initial speed, so reducing by 50%, will reduce the power demand to 1/8, so to 12.5% of the initial speed. Of course, we are losing transport capacity. So to compensate the speed down, we need to put up capacity. As an example, you can see that reducing the speed to half speed will give us a power demand of 12.5% of the initial power demand at full speed. And doubling the size will raise the power demand to 159%. So taking all together, we can say doubling the capacity and halving the speed will give us same transport capacity but 80% less fuel and less CO2. So one very effective solution would be large and slow ships. This is most efficient. Or if large ships are not suitable for the trade, we could say many slow ships. Beyond changing the speed and the capacity of a ship, there are of course a multiple of different options to install technical systems, technical support systems, to use wind power, to use solar power, to use special paints to reduce frictional resistance, to use advanced rudder and propeller design. So there is a big market, and we can say that the most challenging part in this is that we need detailed and transparent information for decision making. Now we will have a look at the fuels. We need low carbon fuels. For example, LNG, liquid natural gas, is being discussed as one promising solution. So let's have a closer look at LNG. So, is it cleaner? Yes, it is cleaner, especially the NOx and SOx and particulate matter will be reduced greatly. But there is no significant advantage in the CO2 balance due to methane slip along the production and logistic line of LNG. On the other hand, there is a high-cost infrastructure ashore and on board the ships needed, as LNG is transported in tanks and has to be cooled down to about minus 160 degrees Celsius. So summarizing, LNG is a clean fuel but not a low-carbon fuel. And it seems not to be suitable for the wide Pacific Ocean region with low volume transport, as the infrastructure is very complex and cost intensive. Perhaps there are other solutions for low carbon fuels. Oftenly discussed and promising seems to be the use of biofuels from coconut oil. There are some questions arising. So coconuts are available at many remote regions, but the question is it enough? There will be a local market which is positive. Production and logistics have to be developed. The economic feasibility is certainly dependent on fossil fuel prices. If fossil fuels remain cheap, it will be difficult to introduce coconut biofuels to the market. What about compatibility with engines? This should be no bigger problem. So it's an interesting option for small-scale transportation in remote areas, but there seems to be some questions, so further investigation and trials are needed. There are other attractive solutions. For example, the direct use of renewable energy from wind and solar power. For example, photovoltaic panels for electric power. They are suitable for main drive of small light craft, for example, passenger ferries. And they are suitable for auxiliary power on all ships. So it's a solution for small craft. The energy density is not high enough for bigger main drives. Using wind power is another option, as it has been done for some 1,000 years. There are nowadays high-performance wind propulsion systems available, for example, Flettner rotors. They are robust systems, fully automatic. The wind is available in many sea areas with high energy density. It can be used for part drive or for the main drive. For example, estimating 2 kilowatt per 1 square meter of projected rotor area on a yearly average basis. Wind propulsion needs a backup propulsion system for the reliability of transport service for the occasion of having no wind available. Summarizing, Flettner rotors are a very effective wind propulsion system, proven technology and suitable for low-cost series production, even locally on a longer term. Finally, let's have a look at the most precious resources we have in shipping, the human resources. With the help of management tools and IT support systems, we can form smart ship operation systems. For example, energy efficiency management on board and ashore, condition monitoring and continuous maintenance, voyage optimization, training programs, incentives for the crew. So there are very many options, and we can summarize that these resources are always available and often underestimated. What's on the horizon for Pacific scale shipping? So in general, meet the special requirements. That means cargo capacity, ship dimensions and speed must be as required. There should be special maintenance concepts suitable for remote areas, which means rather robust technology and repair-friendly technology is needed. Crew must be available to handle the ships and the technology, and that needs specific training. Of course, we need significant savings in fuel and emissions to reach the climate goal. Perhaps it could be wise to concentrate effort and investment by using a common technology base for the whole region. And of course, we need to use renewable energy, wind and solar, whenever possible. And remember, concerning ship speed, the ship should go slow as far as practicable. Let's have a look at some best practice examples. The sailing vessel Quai is a good example for combining ecology and economy. The ship is being operated from Hawaii and serving small South Pacific islands. Perhaps there could be a new, improved edition of sailing vessel. Another example for the use of renewable energy. The Marshall Islands Shipping Company is operating 4 ships of medium size as island supply vessels. They are carrying about 500 tons of cargo capacity. These ships could be enhanced by Flettner rotors, and savings would depend on the retrofit concept, could be up to 50%. This picture is illustrating the way from now, the starting position in the upper left corner, towards a zero-emission shipping world. So at the beginning we have the early movers who demonstrate that sailing is a future technology and can save a lot of energy and fuel. Midterm we will have the wind hybrid ships perhaps dominating the markets that combine modern sail technology with backup propulsion. And in the mid of the century, we will reach the zero-emission shipping with wind and sun and future fuels which are carbon-free. I would like to say thank you, and I hope that this little introduction was helpful. I would be glad to discuss the options in more detail later on. Thank you and bye-bye.